More than 4.6 billion years ago, the universe teemed with the life of stars and clouds of gas. One such cloud began to collapse under its own weight, initiating the formation of a new stellar system. At the center of this cloud, a young sun was being born, the source of energy for the entire system. A protoplanetary disk of dust and gas formed around the young sun. Dust particles began to merge, forming the first bodies, planetesimals. For millions of years, collisions occurred, forming increasingly larger cosmic objects. One of these protoplanets gradually grew. It would become our Earth. The young Earth was a molten sphere, constantly bombarded by debris from space. One of the largest collisions created a cloud of debris from which the Moon was formed. The Earth and the Moon had finally formed, but billions of years of changes lay ahead. The Earth began to cool, forming a primordial crust and a dense atmosphere of water vapor and gases. The first atmospheric gases were released from the Earth's interior during volcanic activity. Magma erupted onto the surface, creating new landscapes and enriching the atmosphere. Constant bombardments from space altered the Earth and brought valuable substances, including water. Comets could have delivered vast amounts of water, which gradually accumulated on the planet. Over time, the water cooled and settled in the depressions. Thus, the first oceans were formed. By the end of the Hadean Eon, the Earth already had oceans and a thin, solid crust. The cooling and stabilization of the climate contributed to the formation of a chemically stable environment. Tectonic forces began to shape the outlines of the future continents. The Earth became a dynamic planet with water, an atmosphere, and active geology. The planet remained active. Magma churned from within, forming new geological layers. Near underwater vents, complex chemical compounds were forming, the foundation for future life. Chemical reactions between water and rocks altered the planet's surface and created new minerals. Storms, lightning, and an active atmosphere created conditions for complex organic chemistry. Simple molecules entered the atmospheric water, the first building blocks of life. Amino acids could have self-assembled into primitive protein chains, the foundation of cellular structures. Simple lipid structures created microscopic protocells, possible precursors of life. Hydrothermal vents in the oceans are a probable site for the origin of the first biochemical processes. Solar energy could have accelerated chemical reactions in the surface layers of the ocean. At the boundary between land and water, unique conditions emerged for the formation of complex molecular structures. Some molecules, like RNA, could store information and self-replicate. The simplest forms of life capable of reproduction gave rise to biological evolution. The first cells used chemical energy to survive in the oceanic environment. Cyanobacteria were the first organisms to start producing oxygen through photosynthesis. Photosynthesis radically changed Earth's atmosphere, saturating it with oxygen. Earth entered a new era, with an atmosphere, oceans, and life that had begun to evolve. Stromatolites are the oldest traces of life that have been preserved on our planet to this day. Microorganisms dominated the world's oceans for billions of years. The rise in oxygen levels changed the chemistry of the oceans and prepared the ground for new forms of life. These banded iron formations are witnesses to the ancient oxygen explosion on Earth. Oxygen began to accumulate in the atmosphere, changing the planet forever. The emergence of eukaryotes was a breakthrough. Life became more complex and organized. The eukaryotic cell emerged through the symbiosis of different microorganisms. Biological diversity began to expand in a favorable environment. The first colonies of cells were a step toward the formation of multicellular organisms. Tectonic movements shaped new continents, changing the face of the Earth again and again. The new landscapes became the stage for the further development of life on land. The very first multicellular organisms emerged in coastal zones. Life began to take on new forms, mobile and complex. Organisms began to leave traces of their activity, the first record in the history of behavior. Earth went through ice ages that influenced the evolution of life. After the glaciation, the climate warmed again. Life resumed its expansion. Marine ecosystems became extremely diverse and stable. Skeletons and shells appeared, providing protection and structure for complex forms of life. Weather conditions favored the transport of nutrients, supporting new ecosystems. The Cambrian explosion was a turning point. Life burst forth with incredible diversity. The Cambrian period gifted the world with complex creatures, many of which have no modern equivalents. The first vertebrates marked an important stage, opening new possibilities for survival and development. Some fish began to adapt to life near the bottom, the first steps toward land. Animals first set foot on land, marking the beginning of a new era of evolution. The first forests created an environment for life on land and enriched the atmosphere with oxygen. These swamps will eventually become a source of coal, the remnants of an ancient plant world. During the Permian period, the first terrestrial vertebrates capable of laying eggs developed. All the continents merged into one giant landmass, Pangaea. Massive eruptions triggered the largest extinction event in Earth's history. Life on Earth rose again from the ruins. Evolution never ceased. After the mass extinction, evolution gifted the world with new giants, the dinosaurs. Dinosaurs quickly adapted to different conditions and became dominant on the planet. Alongside the herbivores, hunters also appeared. The balance of life was restored in new forms. Some species adapted to the aerial environment, conquering the skies. The end of the dinosaur era came suddenly. A threat arrived from space. The catastrophe wiped out most species, but gave a chance to new forms of life. Small mammals survived and began to occupy vacant ecological niches. Mammals quickly evolved, spreading across the earth. Large herbivorous animals evolved, capable of living in dry, open environments. After billions of years of change, Earth has become home to astonishing biodiversity. Plants and insects evolved together, creating colorful and complex ecosystems. Pollination became the foundation of the relationship between plants and animals. Migrations connect continents and maintain balance in natural cycles. Life adapted even to the most extreme and darkest environments. Coral reefs are among the most complex and diverse ecosystems on the planet. The Earth's poles are extremes of climate, yet life has adapted to the cold even there. Even in the heat and droughts of the desert, incredibly resilient creatures thrive. Tropical rainforests are the lungs of the planet and the center of the greatest biodiversity. Mountains are places of isolated evolution, where unique forms of life emerge. Earth is unique in its ability to support life in all its forms. Freshwater ecosystems are hubs of life that connect land and water. Organisms invisible to the eye are the foundation of all ecosystems and the driving force of the planet's biochemical processes. Even a motionless stone preserves the traces of geological history and the passage of time. Life can exist near active volcanoes thanks to the heat and minerals from the Earth's interior. The Earth's crust is constantly in motion. Continents float on the mantle's magmatic currents. The Earth's core generates a magnetic field that protects life from cosmic radiation. The Earth's atmosphere is dynamic. It shapes weather, climate, and the water cycle. Life on Earth is connected by the continuous exchange of matter and energy between forms. Even in the cold, life does not disappear. It changes to survive in new conditions. Earth is the only known planet where life not only exists, but has thrived for billions of years. In every drop of moisture, there is a reflection of the processes that sustain life on Earth. Life is constantly renewing itself, repeating its cycle in countless forms. The seasons are the rhythm in which the planet pulses, offering both life and challenge. The contrasts of Earth are yet another proof of its unique ability to sustain life. The oceans are the cradle of life and a powerful system that influences the entire planet's climate. Even in the harshest conditions, nature finds a way to balance and recover. Geological layers and imprints preserve the memory of Earth's inhabitants from past eras. The universe is vast, but it is Earth that became a unique cradle of life. Every morning, the planet awakens with new energy to continue the great story of life. Earth is an endless diversity of forms, rhythms, cycles, and changes that create harmony. This planet is the result of billions of years of changes, coincidences, and astonishing evolution. Earth is our unique home, created from cosmic dust and transformed into a planet of life. Subscribe to explore the history of Earth's evolution with us.